101 amazing facts about space and our solar system that you can listen to while you fall asleep. The solar system doesn't end at Pluto. In fact, it stretches far beyond into a vast, ghostly expanse called the Oort cloud, a theoretical shell of icy debris that may house trillions of comets. No spacecraft has ever reached this edge, and some scientists believe it could extend up to 100,000 astronomical units, almost 1.5 light-years from the Sun. There's a hexagonal storm at Saturn's North Pole that has baffled scientists for decades. Spanning about 20,000 miles in diameter, the storm is so perfectly shaped that it looks artificial. First spotted by Voyager and later studied by Cassini, its geometric precision continues to defy simple atmospheric models. Venus spins so slowly on its axis that a single day on Venus lasts longer than its entire year. It takes 243 Earth days to complete one rotation, but only 225 Earth days to orbit the Sun. Even stranger, Venus spins in the opposite direction of most planets, meaning the Sun rises in the west and sets in the east. On Mars, sunsets appear blue. This eerie phenomenon happens because the thin Martian atmosphere is filled with fine dust particles that scatter sunlight differently than Earth's. Instead of reds and oranges, the sky dims into a haunting twilight blue when the Sun dips below the Martian horizon. Jupiter's Great Red Spot is a storm so massive it could swallow Earth whole. It's been raging for at least 350 years, though recent data suggest it's shrinking. Winds inside the storm reach speeds of 430 to 680 kilometers per hour, and no one knows why it has lasted so long, or when it might vanish. Neptune radiates more heat than it receives from the Sun, and no one fully understands why. The planet is so far from the Sun that it should be a frozen, lifeless ice ball, but instead it has fierce storms and active weather. Some theories suggest leftover internal heat or exotic atmospheric processes at work. The Moon is slowly drifting away from Earth at a rate of about 3.8 centimeters per year. This seemingly minor movement is having a long-term consequence. Eventually, Earth's rotation will slow, and total solar eclipses will cease to exist. In several 100 million years, no one on Earth will ever witness one again. There's a planet made entirely of diamond, almost 55 Cancri E, located 40 light-years away, is believed to be a carbon-rich planet with extreme temperatures and pressures that likely turned its interior into crystalline carbon. If true, it would make this planet's core a literal diamond mine the size of Earth. Mercury's surface can reach 430 degrees Celsius during the day, yet plunge to minus 180 degrees Celsius at night. That's a swing of over 600 degrees. Because Mercury has virtually no atmosphere to trap heat, the side facing the Sun becomes scorching, while the other side freezes into darkness, a temperature duality almost unmatched in the solar system. Saturn's moon Enceladus has geysers that shoot water vapor, organic molecules, and ice crystals hundreds of kilometers into space. Scientists believe a vast ocean lies beneath its icy crust. These plumes contain ingredients necessary for life, making Enceladus one of the top candidates for alien microbial activity in our solar system. Pluto's heart-shaped region, Tombaugh Regio, is not just a romantic coincidence. It's a frozen plain of nitrogen ice known as Sputnik planitia that may be hiding the subsurface ocean. Its weight may even be shifting Pluto's entire orientation, revealing an unexpectedly active world in the Kuiper Belt once thought inert. Uranus is the only planet that spins on its side. Scientists believe a colossal impact may have knocked it over early in its history. This tilt causes extreme seasonal changes where one pole can face the Sun for 42 years straight before plunging into 42 years of darkness. Earth's magnetic field is weakening, and we don't know exactly why. It's decreased by about 9% over the past 170 years. Some scientists believe it's preparing to flip, where the magnetic north and south poles switch places. If that happens, it could disrupt satellites, navigation systems, and animal migration on a global scale. Mars is home to the tallest volcano in the solar system, Olympus Mons. Standing 13.6 miles high, it dwarfs Mount Everest. It's so wide it could cover the entire state of New Mexico. Olympus Mons is believed to be extinct, but if it were to erupt again, it could change Martian geography drastically. Astronauts in space can't cry like we do on Earth. In microgravity, tears don't fall. They form bubbles around the eyes and can blur vision or even sting. The surface tension makes them float until they're wiped away, creating one of the many unexpected discomforts of zero-gravity life. Space is not completely silent. Though it lacks a medium like air to carry sound, waves of plasma and electromagnetic vibrations can still be detected and converted into audible sound by instruments. NASA has recorded eerie, haunting noises from planets and moons that sound like the soundtrack to a horror film. On Jupiter's moon Io, volcanoes are constantly erupting. It's the most volcanically active body in the solar system due to tidal heating caused by Jupiter's immense gravity. Some plumes shoot lava 300 miles high, reshaping the moon's surface with each eruption and making it one of the most geologically chaotic places known. The sun makes up 99.86% of all the mass in our solar system. Every planet, asteroid, comet, and dust grain combined doesn't come close to outweighing it. This dominance means the sun's gravitational influence extends far beyond Pluto, effectively anchoring the entire system for billions of years. In 1977, the Big Ear radio telescope picked up a 72-second-long radio signal from deep space, now famously known as the WOW signal. It was never repeated and remains unexplained. Some scientists suspect it could be an artificial signal, possibly even a message from an extraterrestrial civilization we've never heard from again. Some meteorites found on Earth originally came from Mars. Powerful impacts ejected rocks from the Martian surface into space, where they eventually collided with Earth. These alien rocks provide valuable clues about Mars' past climate and geology, and might one day confirm whether life once existed on the red planet. There is a region between Mars and Jupiter known as the asteroid belt, but it's not the dense minefield often portrayed in movies. If you flew through it, you'd likely never see an asteroid up close. Still, it contains billions of objects, including some the size of dwarf planets, that could pose threats to Earth if perturbed from their orbits. The Sun's atmosphere, the corona, is mysteriously hotter than its surface. While the visible surface reaches around 5,500 degrees Celsius, the corona spikes to over 1,000,000 degrees. This paradox has puzzled astrophysicists for decades, with theories pointing to magnetic reconnection and plasma waves, but the exact mechanism remains one of solar science's most enduring mysteries. Despite being one of the most hostile environments in the solar system, the planet Jupiter might have a solid core. Beneath its crushing layers of hydrogen and helium lies a mysterious, possibly Earth-sized core of rock or metallic hydrogen, yet no probe has penetrated deep enough to confirm its true nature. The International Space Station travels at about 28,000 kilometers per hour and orbits Earth roughly every 90 minutes. That means astronauts on board witness 16 sunrises and sunsets each day. While it sounds beautiful, the constant light-dark transitions wreak havoc on their circadian rhythms and require carefully controlled lighting schedules. Space is full of deadly radiation, especially beyond Earth's magnetic field. Cosmic rays and solar particles can pass through spacecraft and human tissue, causing long-term health effects. Prolonged exposure could lead to cancer, cognitive issues, or acute radiation sickness, making deep space travel one of humanity's most dangerous undertakings. One day on Jupiter is only about 10 hours long, making it the fastest spinning planet in the solar system. This rapid rotation flattens it slightly at the poles and contributes to its chaotic banded atmosphere, which is riddled with powerful storms and jet streams that make weather predictions nearly impossible. There are lakes of liquid methane and ethane on Saturn's largest moon, Titan. Its surface is eerily Earth-like, with rivers, clouds, and even rain. But instead of water, it's hydrocarbons. This makes Titan one of the most alien yet familiar places in our solar system, with conditions that may harbor exotic life forms. Earth has a second moon called 3753 Cruthen. It doesn't orbit Earth in a traditional sense, but follows a horseshoe-shaped path in resonance with our planet's orbit around the Sun. This co-orbital relationship means it's sometimes close to Earth, yet not gravitationally bound as a natural satellite. Comets are essentially dirty snowballs, but they're capable of lighting up the solar system when they approach the sun. The heat causes their icy nuclei to vaporize, creating glowing tails that can stretch for millions of kilometers. Some comets leave behind meteor showers as Earth passes through their debris trails. Scientists believe that solar flares and coronal mass ejections could one day knock out global power grids. A powerful solar storm like the 1859 Carrington event would devastate modern infrastructure, destroy satellites, and leave large portions of the world in the dark for months or even years if unprepared. The Kuiper Belt is home to thousands of icy bodies beyond Neptune, but it's still a cosmic mystery. It's thought to be the birthplace of short-period comets and possibly a hiding place for the hypothetical Planet 9, a planet many believe is hiding in the distant dark, pulling objects with its unseen gravity. Time moves differently in space due to Einstein's theory of general relativity. Astronauts aboard the ISS age ever so slightly slower than people on Earth due to their speed and orbital position. This effect, though tiny in practice, has been measured and confirmed, meaning technically, astronauts return home younger by microseconds. Our solar system is moving through the galaxy at 828,000 kilometers per hour. Even though we orbit the sun itself orbits the center of the Milky Way, dragging the entire solar system along with it. It takes about 225 million years to complete one galactic orbit, a journey we've done only a few times. The vacuum of space doesn't mean temperature doesn't exist. Instead of air temperature, objects heat or cool based on radiation. For instance, in direct sunlight, an object in space can reach 120 degrees Celsius, but in shadow it may plunge to minus 170 degrees Celsius. This harsh swing makes spacecraft design incredibly difficult and dangerous. If you fell into a black hole, you'd undergo spaghettification, a gruesome process where gravity stretches your body into long, thin strands due to extreme tidal forces. Time would slow down for you relative to an outside observer, and eventually, you'd vanish beyond the event horizon, your fate sealed by physics. The Milky Way is on a collision course with a neighboring Andromeda galaxy. In about 4.5 billion years, the two galaxies will merge in a cosmic dance. Despite the scale, stars will rarely collide directly due to the vast space between them, but the night sky will never look the same again. Every planet except Uranus and Venus rotates counterclockwise. Venus rotates clockwise very slowly, making its day longer than its year. Uranus, meanwhile, rolls on its side with an axial tilt of 98 degrees, leading to the most extreme seasons in the solar system and adding bizarre diversity to planetary behaviors. Solar sails are a real concept for space propulsion. They work by harnessing the momentum of photons from sunlight to propel spacecraft. Though incredibly slow to accelerate, they require no fuel, and over time, they could reach incredible speeds, potentially enabling interstellar missions in the distant future. It rains diamonds on Uranus and Neptune. The immense pressure in their atmospheres compresses carbon into diamond crystals that likely fall through layers of gas before vaporizing or settling deep inside. This surreal phenomenon could mean that parts of these planets literally sparkle from the inside out. A teaspoon of a neutron star would weigh around 6 billion tons. These collapsed stellar remnants pack more mass than the Sun into an area the size of a city. Their gravity is so intense that atoms collapse, electrons and protons merge, and matter enters a phase found nowhere else in the universe. Pluto was demoted from its planetary status in 2006, but what many don't know is that its orbit actually crosses inside Neptune's orbit for 20 years every 248-year cycle. Despite this apparent intersection, a gravitational resonance between the two keeps them from ever colliding, an intricate cosmic dance governed by celestial mechanics. There are rogue planets drifting through the galaxy with no star to call home. These planet-sized objects were likely ejected from their original solar systems and now float in total darkness. Scientists estimate there may be billions of them, raising eerie possibilities about what might exist in these cold, sunless worlds. Saturn's rings, while breathtaking, are slowly disappearing. The planet's gravity is pulling them in at a rate scientists call ring rain. Within 100 million years, a blink in cosmic time, the rings may completely vanish, turning Saturn from a majestic gas giant into just another striped planet. The Great Red Spot on Jupiter has been raging for at least 350 years, and possibly much longer. This massive storm is large enough to swallow Earth whole and is slowly shrinking. No one knows exactly why it's persisted so long or why it's beginning to fade after centuries of dominance. Earth's magnetic field occasionally flips, with the north and south magnetic poles switching places. This doesn't happen overnight, it can take thousands of years. But during the transition, Earth's protective shield weakens, allowing dangerous solar and cosmic radiation to seep through. The last full flip was over 700,000 years ago. Solar eclipses are only possible because the sun is 400 times larger than the moon and also 400 times farther away, making them appear almost exactly the same size from Earth's perspective. This perfect alignment is a rare cosmic coincidence and won't last forever as the moon is slowly drifting away. Venus, often called Earth's twin, is actually more like its evil sister. Its surface temperature exceeds 460 degrees Celsius, hotter than Mercury, even though it's farther from the sun. Its dense atmosphere is made of carbon dioxide and sulfuric acid clouds, creating a runaway greenhouse effect and possibly a warning for Earth's future. The heliosphere is a vast bubble created by the sun's solar wind, encompassing the entire solar system and shielding it from interstellar radiation. Voyager 1 crossed this invisible boundary in 2012, entering interstellar space. The edge of this bubble is not fixed. It warps and ripples like a cosmic heartbeat. Mars has the tallest volcano in the solar system, Olympus Mons. This monstrous shield volcano stands about 22 kilometers high, nearly 3 times the height of Mount Everest, and is so wide that its base would cover the entire state of New Mexico. Its sheer size defies anything seen on Earth. Cosmic dust constantly rains down on Earth, about 100 tons of it every day. This fine, microscopic debris originates from comets, asteroids, and interstellar space. Over millions of years, it accumulates in Earth's crust, ocean beds, and even in your body, subtly tying humanity to the cosmos. Mercury has no atmosphere to speak of, but temperatures still swing from 430 degrees Celsius during the day to minus 180 degrees Celsius at night. This extreme fluctuation makes it one of the most inhospitable places in the solar system, despite being the closest planet to the Sun. Io, one of Jupiter's moons, is the most volcanically active body in the solar system. Its surface is dotted with hundreds of volcanoes, some spewing plumes hundreds of kilometers high. These eruptions are powered by tidal heating from Jupiter's immense gravity squeezing and stretching Io's interior. The solar system is about 4.6 billion years old, but the oldest object we've ever touched is a microscopic speck of stardust inside a meteorite found in Australia, estimated to be over 7 billion years old. It predates the Sun and offers a glimpse into the galactic nursery that birthed our star. Neptune's winds are the fastest in the solar system, reaching speeds over 2,000 kilometers per hour. These supersonic winds, blowing through an atmosphere composed mostly of hydrogen, helium, and methane, create dark storms that make Earth's hurricanes look like gentle breezes by comparison. The Moon is slowly moving away from Earth at a rate of 3.8 centimeters per year. This may not sound like much, but over millions of years, it significantly affects Earth's tides and rotation. Eventually, total solar eclipses will no longer be possible, as the Moon will appear too small to cover the Sun. The Sun accounts for 99.86% of the total mass of the solar system. That means all the planets, moons, asteroids, and comets combined make up just a tiny fraction. This overwhelming dominance is why the Sun's gravitational pull controls everything, from Mercury's tight orbit to distant comets in the Oort cloud. The Moon has no atmosphere, so its sky is always pitch black, even during the day. Because of this, Astronauts standing on the moon can see stars during the lunar day, something impossible from Earth due to atmospheric scattering. It's a surreal, dreamlike view of the cosmos. Enceladus, a small icy moon of Saturn, shoots massive geysers of water vapor and organic material into space from cracks in its surface. These plumes come from a subsurface ocean that may contain life. NASA is seriously considering a mission to fly through or land near these jets to search for alien microbes. The asteroid Vesta is so large and bright that you can sometimes see it with the naked eye from Earth. Measuring over 500 kilometers across, it's one of the few asteroids with a differentiated interior like a planet, featuring a core, mantle, and crust, hinting at an aborted planetary destiny. A single bolt of lightning on Earth can release enough energy to power a small town, but the storms on Saturn are far more powerful. Saturnian lightning has been observed by the Cassini spacecraft to last for weeks and generate radio waves strong enough to be detected across vast distances in space. The Kuiper Belt, a vast region beyond Neptune, is home to thousands of icy bodies, including dwarf planets like Pluto and Eris. But what's unsettling is how little we know about this region. It's suspected to hide unknown planets or massive dark objects, lurking beyond the reach of most telescopes. The Sun's surface looks calm from Earth, but it constantly seethes with magnetic activity. Solar flares and coronal mass ejections can hurl billions of tons of charged particles into space at incredible speeds. If aimed at Earth, they can cripple satellites and power grids, effectively pushing us back into the 19th century. The far side of the Moon, which we never see from Earth due to tidal locking, is vastly different from the near side. It's more mountainous and heavily cratered, with fewer lava plains. This asymmetry has puzzled scientists for decades, and its origins remain one of lunar science's most enduring mysteries. There is a bizarre hexagonal storm at Saturn's North Pole, perfectly geometric and persistent for decades. No other planet in the solar system has anything like it. Scientists still don't fully understand what causes this stable six-sided pattern, but it suggests Saturn's atmosphere operates on truly alien physics. Triton, Neptune's largest moon, orbits in the opposite direction of Neptune's rotation, a retrograde orbit. This suggests it was likely a captured object from the Kuiper Belt. Its retrograde motion makes it unstable in the long term, and eventually, it may be torn apart by Neptune's gravity and form a new ring. Ceres, the largest object in the asteroid belt, has water ice beneath its surface and mysterious bright spots inside its craters. These bright spots are salt deposits, possibly left behind by briny water that reached the surface and evaporated, evidence that Ceres may have once had a subsurface ocean. Our solar system is moving through the Milky Way at an astonishing speed of about 828,000 kilometers per hour. Even at that velocity, it takes about 230 million years to complete one orbit of the galactic center, a journey humans have never consciously completed even once. Despite Mercury being the closest planet to the Sun, it's not the hottest. Venus holds that title. But here's a twist. Mercury can experience freezing temperatures at its poles. Deep craters that never see sunlight hide water ice, preserved for billions of years even in a scorched world. There is a region beyond Pluto called the Oort cloud, theorized to be filled with icy debris and dormant comets. It is so distant that light from the Sun takes over a year to reach it. We've never directly seen it, yet it's believed to surround our solar system like a giant cosmic shell. The Sun's core produces energy through nuclear fusion, where hydrogen atoms are forced together to create helium. But the photons generated in the Sun's core take up to 170,000 years to reach the surface, bouncing around in a chaotic interior before finally escaping as sunlight. There are places in our solar system where rain doesn't fall as water, but as methane. On Saturn's moon Titan, it rains liquid methane from a thick, hazy atmosphere. Titan even has rivers, lakes, and seas, though filled with hydrocarbons instead of water, forming an alien but eerily Earth-like hydrological cycle. The moon has no atmosphere to protect it from space debris, so its surface is covered with millions of impact craters. Some of these impacts are recent enough that we've observed them from Earth telescopes in real time, watching new scars form on our closest celestial neighbor. Comets are often called dirty snowballs, but they can unleash massive jets of gas and dust as they approach the sun. These volatile reactions can create coma clouds thousands of kilometers wide, and some comets even break apart completely, destroyed by the very star that lights their journey. Jupiter emits more heat than it receives from the sun. Its immense gravity and composition allow it to generate internal heat, likely from the slow gravitational compression of the planet. This internal furnace powers its massive storms and possibly keeps some of its moons geologically active. The Sun makes up 99.86% of the solar system's mass, but Jupiter alone holds about 70% of the remaining planetary mass. If Jupiter had been just 80 times more massive, nuclear fusion could have begun in its core, and it would have become a small star, our solar system's failed second sun. Some asteroids have their own moons. This discovery shocked astronomers, as even tiny objects in space can have enough gravity to capture smaller companions. These binary or even triple asteroid systems challenge our understanding of how gravity shapes bodies in space, even at the smallest scales. If Earth lost its magnetic field, we'd be bombarded by solar and cosmic radiation. The magnetosphere acts like a giant force field, deflecting charged particles from the sun. Without it, our atmosphere could slowly erode, water might evaporate into space, and life would be left dangerously exposed. A day on Venus is longer than its year. Venus takes about 243 Earth days to complete one rotation, but it orbits the Sun in just 225 Earth days. This bizarre spin also causes the Sun to rise in the west and set in east, opposite of Earth. When stars die, they can go supernova, creating shockwaves that seed galaxies with heavy elements. The iron in your blood, the gold in your jewelry, and the calcium in your bones were all forged in ancient stellar explosions. In that sense, every human being is literally made of stardust. Jupiter's moon Europa is covered in a thick layer of ice, but beneath it lies a vast ocean of liquid water, possibly twice the volume of all Earth's oceans combined. Scientists believe hydrothermal vents on Europa's seafloor could harbor microbial life, making it one of the most promising targets for astrobiology. Mars experiences massive dust storms that can engulf the entire planet and last for months. These storms can block sunlight so thoroughly that solar-powered rovers like Opportunity lost functionality. Imagine a planet where the sky disappears in a haze of rust-red darkness for weeks at a time. Enceladus, a moon of Saturn, ejects massive plumes of water vapor from cracks in its icy surface. These geysers shoot material hundreds of kilometers into space and feed Saturn's earring. Scientists believe a salty subsurface ocean may exist below the ice, possibly heated by tidal forces and containing life-friendly chemistry. Even now, we don't fully understand why the Sun's outer atmosphere, the corona, is millions of degrees hotter than the surface. This coronal heating problem defies expectations. It's like stepping farther away from a fire and getting burned more. Some theorize tiny magnetic explosions are responsible, but it remains unsolved. Pluto's heart-shaped glacier, Sputnik Planitia, is a massive plain of nitrogen ice, and it seems to be in gravitational equilibrium with a subsurface ocean. That means Pluto, tiny, cold, and distant, might have liquid water beneath its crust, defying assumptions about how dead a dwarf planet can really be. The asteroid 16 Psyche is one of the most valuable objects in the solar system. It's made almost entirely of metal, mostly nickel and iron, and some estimates put its worth at over $10 quintillion. NASA plans a mission to explore it, possibly revealing the exposed core of a failed planet. In 1994, fragments of comet Shoemaker-Levy 9 slammed into Jupiter with explosive force, creating fireballs larger than Earth. The scars lingered for months. This was humanity's first direct observation of a cosmic collision between large bodies, and a terrifying reminder of what could happen to Earth one day. Saturn's moon Iapetus has a bizarre feature. One hemisphere is bright as snow, and the other is pitch black. It also has a strange equatorial ridge that makes it resemble a walnut. These mysterious features suggest violent impacts, unknown material exchanges, or a dramatic thermal history we still don't understand. Some regions of Mars feature recurring slope-linear dark streaks that appear seasonally and may be signs of briny liquid water seeping out of the ground. If confirmed, this would be direct evidence of present-day liquid water on Mars and potentially habitable conditions under the right circumstances. The heliosphere, the bubble of solar wind surrounding our entire solar system, acts like a protective shield against galactic cosmic radiation. But it's not uniform. Recent data from Voyager probes show it may have a strange shape, more like a croissant than a sphere, affected by interstellar magnetic fields and unknown forces. Neptune radiates over twice the heat it receives from the Sun. Despite being so far away and frigid on the surface, it has an incredibly dynamic atmosphere with the fastest winds in the solar system, reaching speeds of up to 2,100 kilometers per hour. Where that energy comes from is still debated. The Moon is slowly drifting away from Earth at a rate of about 3.8 centimeters per year. Millions of years from now, total solar eclipses will no longer be possible because the Moon will appear too small in the sky to fully cover the Sun. Jupiter's Great Red Spot is a massive storm that's been raging for centuries. It's so large that Earth could fit inside it with room to spare. However, this storm is gradually shrinking and may eventually disappear entirely. Its end could mark the loss of one of the solar system's most iconic features. Solar flares from the Sun can cause space weather that affects technology on Earth. These energetic bursts can disrupt GPS, communication systems, and even damage power grids. The most powerful known solar storm, the Carrington event in 1859, caused telegraph systems to spark and catch fire. The asteroid belt between Mars and Jupiter is not densely packed with rocks like in sci-fi movies. In fact, it's mostly empty space. If you were standing on an asteroid, you'd likely need a telescope just to see the next closest one. It's a cosmic desert, not a debris highway. Venus rotates extremely slowly and in the opposite direction of most planets. Its day lasts longer than its year, and due to its thick atmosphere, temperatures remain hot enough to melt lead, day or night. Even spacecraft sent there have lasted only hours before being crushed or melted. Uranus is the only planet that rotates on its side, tilted over more than 90 degrees. Scientists believe it suffered a colossal impact early in its history. This odd tilt causes its poles to experience 42 years of sunlight followed by 42 years of darkness, an eerie, frozen twilight world. The Sun is slowly getting hotter. Over the next billion years, its increasing energy output will evaporate Earth's oceans and sterilize the planet. Long before it becomes a red giant and engulfs Earth, the planet may already be uninhabitable due to this gradual solar brightening. Comet tails always point away from the Sun, regardless of the comet's direction of travel. This is because the solar wind and radiation pressure push the dust and gas away, forming the characteristic tail. Sometimes comets even develop two tails, one of gas and one of dust, traveling in slightly different directions. A single teaspoon of a neutron star would weigh around 6 billion tons. These stars are the collapsed cores of supernovae, and their density is so extreme that atoms themselves are crushed. Their surface gravity is so strong that falling from a meter high would vaporize you instantly. If Betelgeuse, the red supergiant in Orion, goes supernova, it will be visible from Earth even during the day for weeks. While it's 642 light-years away and poses no threat, witnessing a supernova in real time would be one of the most extraordinary events in human history.